Hello everyone, this is Aisri and welcome to my channel. So in this video, let us answer an important question for engineering physics, that is construction of Ruby laser and working of Ruby laser. So in this video, I am going to clearly explain you the construction of Ruby laser with the help of diagram and the working of Ruby laser with the help of diagram. So first of all, let us see who discovered or who is successful in discovering this successful laser is T. Myman in the year 1960, and it is three level laser. So it is three level laser. What are the three levels means? Ground level, excited level and the metastable level. And this Ruby laser is an example of solid state laser. We know the ground level. Excited level means it acquires some energy and go to the excited level. And here it can have lifetime up to 10 to the power of minus 8 seconds. Here it will have lifetime of about 10 to the power of minus 3 seconds. So here it will have more lifetime than the excited level. So these are the three levels and it is an example of solid state. So to construct a Ruby laser, we have three main parts. One is active medium, resonant cavity and the exciting system or the pumping system. So in the same way, so the Ruby laser also have the active material or the active medium. An active working material is the ruby crystal itself. So a rod of ruby crystal is used as a working material. What is this ruby crystal? Means ruby is a crystalline substance of aluminum oxide Al2O3 doped with approximately 0.05 by weight of chromium. So it is doped with aluminum oxide Al2O3 is doped with the chromium Cr2O3. And this rod is in pink color because the resultant pink color is due to presence of Cr3 plus ions in the appropriate concentration, which replaces aluminum atoms in the crystal lattice. So why it is in pink color or the red color means, so sometimes it is maybe in red color because here we have Cr3 chromium ions. So these chromium ions replaces the aluminum atoms Al3. Al plus 3 atoms are replaced by these Cr3 plus. So because of these it will get pink color. So these chromium ions only participate in the laser transition. And the length of the ruby laser is 4 centimeters. So sometimes it is maybe 2 to 30 centimeters also. And the diameter is 0.5 centimeters and it sometimes maybe 0.5 to 2 centimeters. So this is the construction of the ruby laser. So we have active medium. So that is ruby rod. So here we have active medium. So next what we have need energy source. So the energy source is needed to pump the chromium ions to the excited states. So what is the energy source or the pumping source? Is a helical xenon flash tubes. So these are the helical xenon flash tubes. So these tubes are the energy sources. So what happened with these energy sources means the chromium atoms are raised to excited state by optical pumping using helical xenon flash tube. So the electrons or the atoms in the ground state, they will absorb energy and they will go to excited state due to the helical xenon flash tubes. And the xenon flash tubes emit thousands of joules of energy in a few milliseconds and tube consumes several thousand joules of energy. Only a part of energy is used to exit the chromium ions and the rest of heats the apparatus, so cooling arrangement is used. So here what happens means, here we use xenon flash tube to excite the ground state atoms to the excited state atoms. So when a power source is connected, so these xenon flash tube, so when a power source is connected, this xenon flash tube will emit a lot of energy in few milliseconds. In seconds, it will emit lot of energy, but only some energy is used to excite the chromium ions. So remaining energy will remain as a heat. So because of this heat, we use a cooling system. So here we have cooling system, right? So here we use cooling system in order to cool the apparatus. Why we get heat means only part of energy is used, which is supplied by the power source with the help of xenon flash tubes. So because of the reason we use cooling system. So what is the purpose of energy source means? To excite the chromium ions from the ground state level to the excited level state. Next. And the third one is resonant cavity. So here resonant cavity are the end faces of the rod are made strictly parallel grounded and polished to high degree. the end faces and then silvered in such a way that one end face become fully reflected while the other end partially reflected. Let us see the diagram, then we can understand better. So this is ruby rod, right? So these two ends of the ruby rod are covered with the end faces, and these two are parallel to each other. These two are end faces are parallel to each other, in which one rod is fully reflecting, means it does not allow any of the laser outside. But here we can see it reflects some of the light and it does not reflect. So it is partially reflecting end face. So here we have two end faces. One is fully reflecting and the other one is partially reflecting. So after the light amplification, the laser will come from the partially reflecting one. Okay, so here we use resonant cavity as these two end faces in which they are parallelly grounded, and also one end is fully reflecting and the other end is partially reflecting. So this is the construction of the ruby rod. Now let us see the working. How does it work to produce a laser beam? Means, so let us see the diagram. So this is the ground level. So ground level is named as E1 and E3 is excited state. So when the chromium ions absorb energy, they will excite to the excited state, that is E3. And after some time, they will return to the E2 level, that is metastable state. Now let us see how the process goes on. So with the help of power source, the xenon flash tubes will acquire energy, and that energy is acquired by the chromium ions. So here it is a 3-level laser diagram, right? So this is 1, 2, 3. And first, the chromium ions will absorb some energy from the xenon flash tubes. Then they are excited to the E3 level, so the excited level. So what is the lifetime here? 10 to the power of minus 8 seconds. So here they will absorb the energy of 5500 angstroms. So by absorbing these light energy, they will get some energy in the ground state and they will go to the excited state, E3. Next, the excited ion gives a part of its energy to the crystal lattice and decay without giving any radiation. So after going to the excited state, it will come down to the E2 metastable state without giving any energy, any radiation, it will come down. So that is, this transition is called radiationless transition. So first the chromium ion will absorb some energy from the helical xenon flash tubes of light 5500 angstroms and jump to the excited state E3, and it comes to the E2 metastable state after 10 to the power of minus 8 seconds with a radiationless transition. So here we already know that metastable state have more lifetime, that is 10 to the power of minus 3. Since metastable E2 has much longer time, that is 10 to the power of minus 3 seconds, the number of ions in E2 increases. So here first we jump to the excited state, after it comes to the E2. So here we can see that the ions will increase. The number of ions will increase in the metastable state, because after 10 to the 8 seconds it will come to the metastable state. But here we have 10 to the power of minus 3 seconds, so more lifetime. So as a result, here we have more number of ions as compared to the ground state. So as we have more number of ions in the E2 states as compared to the E1 state, here we can achieve the population inversion. So here we achieved population inversion. So how we have to write? Since metastable state E2 has much longer lifetime, 10 to the power of minus 3 seconds, the number of ions in the E2 increases. So E2 increases. Thus population inversion is achieved between the states E2 and the E1. So here we achieved population inversion between E2 and E1. So here we have 10 to the power of 8 seconds. Here we have 10 to the power of minus 3 seconds. So after 10 to the power of 8 seconds, it comes to the metastable state. In the same way, after 10 to the power of minus 3 seconds, again it will come to the ground level. So when it comes to the ground level, it is spontaneous emission. So with the spontaneous emission, it releases a photon, that is 6943 angstroms energy photon is released with the spontaneous emission. So first ground level to the excited state and the excited state to the metastable state. So after 10 to the power of minus 3 seconds with the spontaneous emission, the ion will come to the ground state by emitting a photon with the energy 6943 angstroms. So now what this photon do? Means this photon This photon moves back and forth. So this side to this side, this side to this side, and what it will do means it will trigger the another chromium ion to do the stimulated emission. So first of all, an photon is released due to the spontaneous emission. This photon will move back and forth in the ruby rod, and it will trigger the another chromium ion to do the stimulated emission. And because of that stimulated emission, another two photons are produced with the same one, the same energy, that is the 6943 angstroms. 6943 angstroms. Again these two photons again will trigger another two chromium atoms and produce 4, and again it will multiply up to 16, like that. So the amplification goes on. So because of this light amplification goes on, and these photons will move in the reflecting, partially reflecting end phase and the reflective, fully reflecting end phase, and finally after getting maximum energy the photons will appear as a beam, laser beam. So see, the photon travels through the ruby rod and is reflected back and forth by silvered end until it stimulates other excited ion. Here other excited ion means chromium ion, and it causes to emit a fresh photon in phase with the stimulating photon. So what here happens is one photon which is emitted due to the spontaneous emission. So when it comes to the 10 to the power of minus 3 seconds in the metastable state to the ground state, it will come as a spontaneous emission. So this photon will trigger another chromium ion to cause a stimulated emission. So this stimulated emission produces a fresh photon. So because of this we got two photons with the energy of 6943 angstroms. Again these two photons trigger another two chromium atoms in the excited state. So simply we can write this photon travels from through ruby rod and stimulated an excited atom. The excited atom emitting photon and return to the ground level. This state transmission is a laser transmission. So instead of writing all this, you can write simply this photon travels through the ruby rod and stimulated an excited atom. The excited atom emitting photon and return to the ground level. This state transmission is laser transition. And what happens? This process is repeated again and again. This results amplified strong laser beam is emitted by the wavelength 6943 angstroms. So when the photons get maximum energy, they will appear as a laser beam through partially silvered end of the crystal. So now let me conclude how the process goes on again. So first of all, there are some chromium ions. They will absorb some energy from the helical xenon flash tube, and they will go to the excited state E3 level with the pumping transition by absorbing 5500 angstroms energy, and they will go to the excited state. Here it is having less mean lifetime, that is 10 to the power of 8 seconds. So after reaching 10 to the power of minus 8 seconds, it will come to the metastable state. Here we have more lifetime, that is 10 to the power of minus 3 seconds. Here we can see radiationless transition. So after that, after 10 to the power of minus 3 seconds, again it will come to the ground state, right? So it will come to the ground state by emitting a photon of 6943 angstroms energy. So here spontaneous emission takes place. Now this photon will do all the things. So this photon will trigger another chromium ion. So the chromium ions will be here or the here. So the chromium ions will be triggered by these photon, and they will move in the uh, end faces of the ruby rod. Here we have two reflecting surfaces, right? Partially reflecting and fully reflecting end faces. They will move back and forth, and they will trigger the atoms, chromium ions, in these excited state and the metastable state, and because of this they will appear as two photons. So a fresh photon is created because of this collision. So these two photons with the energy 6943 angstroms. Again these two photons triggers another two chromium ions and produce 4. Again that 4 will produce 8. So in that manner the light amplification takes place. So after light amplification takes place, at a certain value it will reach maximum value. So at that time it will appear as a laser beam. In this way the process goes on. So what happens after some time? So here the chromium ions, and here chromium ions will be triggered by these photon atoms. So because of that, the population inversion doesn't take place, because after some time in the ground level the ions will increase, so there is no population inversion. So after some time, again the same process goes on, again we will get population inversion. So because of this we will get pulsar laser. Why? Because after some time we cannot have the population inversion. If you see the characteristics of ruby laser, active medium we used is ruby rod, which is made up of Al2O3, and pumping is xenon flash tube. Xenon tube optical resonator is highly polished and silver coating, and wavelength of output. So what is the wavelength of output? With the 6943 angstroms we are getting the laser beam, and the nature of the output is pulse laser, because the population is inversion is not constant always. So after some time there is no population inversion, again the process goes on, again we will get population inversion. And the drawbacks: laser require a high power pumping. Here it will require high power pumping, then only the xenon flash tube will acquire energy, and that energy is given to the chromium ions. And it is pulsar laser, so we cannot get the continuous laser, we get only pulsar laser. And imperfection of the crystal means it contains some impurities, means here it is doped, right? So it is imperfection of the crystal. And the efficiency of the ruby laser is very small, only the green component of the pumping light is utilized. So only some component only used, remaining is not used, and it will appear as a heat. So to remove that heat we use again the cooling system. So these are the drawbacks. Next, applications: it is used in laboratory experiments, soldering and welding, to test the quantity of the material, and it is used in the treatment of detached retina. So retina, we know, right? So it is used in the light detection and ranging lidar.